So we are done using our superposition theorem. So we're now using our source of transformation theorem and problem number 1 in assignment number 4. So now from the given diagram, which is the figure 2, which is this one. So transform this into this one. So I will explain it to you. How did I transform it? So we solve for equivalent of every power source into a current source. So in solving our current source, which is can be solved by our ISA is equal to A over RA, which is 24 over 0.2, which is equal to 120 ampere. Then our ISB, or the current source letter B, so AB over RB is equal to 26 over 0.3, or 260 over 3 ampere. So solve for IS. So ISA plus IB will be equal to 120 plus 260 over 3, which is equal to 620 over 3. So this is our current source. So after that, we will have um, simplify this diagram so into this one. So as you can see, um, we add the two current source, so it will have 620 over 3 to make it simpler. So we'll have now our 620 over 3 as our current source. So we can now solve for IL. So IL can be solved for 1 over RL over 1 over RA plus 1 over RB plus 1 over RL. So substitute. So RL is 0.5 ohms, RA is 0.2 ohms, RB is 0.3 ohms, RL is 0.5 ohms. So times our IS is 620 over 3. So by typing it in a calculator, we will have a result 40 ampere. So we are done solving our IL. So now we will solve our IA and IB. So our IA, solve for IA is equal to IS, our current source, I mean, over 1 over RA plus 1 over RL plus 1 over RB. So by simply substitution of the values, so 620 over 3 over 1 over 0.2 plus 1 over 0.5 plus 1 over 0.3. Then it will have a result of 20 ampere by simply calculating it using a calculator. Then solve for IB. So our IB is can be solved using applying a KCL. So using the equation, IA is equal to IA. Let us show first this for real solution. So IA is plus IB minus IL is equal to 0. So solve for IB, we will have IB transpose IA and IL, so negative IA plus IL is equal to our IB. So by simply substituting the given value, our negative IA is 20 plus IL is 40. So it will have negative 20 plus 40 is 20 ampere. So this is our IB. So solve for VL. So VL is, we know that V, or the source, is equal to I times R, or current times resistance. So VL, IL, RL. So we can now solve 40 times 0.5. So we have the value for our VL as 20 volts. So now next is solve for PA. Solve for PA, PB, and PL. So solving to these three, so we can have our formula is P I R squared, I squared R, I mean. So substitute. So our PL is IL squared RL. So it will have 40 squared times 0.5. So it will result 800 watts. So PB is equal to IB squared RB. So 20 squared times 0.3. So it will have 120 watts. Then PA is equal to IA squared RA is equal to, so substitute the given value, 20 squared, our R is 0.2, so it will have 80 watts. So that is all for our, what do we call this one, super, I mean source of transformation theorem.